Welcome, Tactical Technician Diagnation. Today's video is going to be called Grounds. And here's your schematic in front of you there. Take a little screenshot of it. And we're going to be on 4 channels. And we're going to talk about this particular setup. And if there a situation presents itself that we need to set things like that up like this, it has a kind of a pragmatic reason. If we were ever dealing with a situation where we had a no crank, let's say we had a marginal or no communication with a scan tool, we had a very poorly running engine that's had a bunch of parts maybe from another shop, and we want to kind of prove out the integrity of the ground circuits because they can affect so many different things when they become faulty. Here we see an illustration. Basically in the middle you see the engine block. That's where pretty much all our grounds are hardwired to. Below that is the PCM, and we're going to deal with 4 hookups here. We're going to deal with a fuel injector, an ignition coil, a map sensor, and basically the engine block itself to the battery negative terminal. All the scope channels are grounded to the battery negative terminal. As we look at a situation like this, we look at the PCM and just take a look at the fuel injector. I'll kind of pan in on it, and you can see the fuel injector goes in. It goes into the PCM. The transistor controls the on time through the logic, and its current has to actually come out of the PCM and flow to the engine block and flow back to the negative battery terminal, or of course the back of the alternator, whichever we consider the most negative part of the vehicle. So that circuit's always got to be good, and our channel A is going to check that circuit. Channel B is going to be at the negative side of the ignition coil. It's not the pulsing side on this particular coil. It's going to be hardwired to the engine block on this Honda 3-wire coil. The logic, the trigger comes from the PCM, and the PCM needs good ground for its logic to function properly. So, of course, grounds are important in that respect. So we're going to be looking at that particular ground. The third ground is the map sensor ground. That's a sensor ground. And that's the map sensor, obviously plumbed into the intake manifold to sense vacuum. Has 3 wires, a 5-wire, a signal wire, and a ground wire. If you follow that ground wire, it goes from the map sensor back into the PCM, and it comes out as a logic ground. Now that's a very simplified illustration here, but nonetheless, it still has to be an uncompromised circuit to get back into the PCM, out to the engine block, and of course, it has to get back to the negative side of the battery. And all that stuff has to be within a certain voltage drop level. If it's elevated, it's problematic. So I just want to show you the illustration. I'm going to get in the car. I have the scope set up, and I will show you what I'm on. Channel A is the injector. Channel B is the negative side of the coil, the ground of the coil. Channel C is the map sensor ground, and channel D is the engine block. So what I'm going to do a key on for about a second, then I'm going to crank, and then I'm going to run, and I'm going to shut it off. I'm going to try to get it in one shot. I'm dealing at 1 second per division here. I'm on 50 volts for A with the fuel injector, go to the flyback voltage. The other 3 channels are 5 volts because that voltage drop should stay within with the 5-volt range. It shouldn't be up near the 5-volt range. So here we go. I'm going to put the key in. I want to get a full screen. Here we go. Keys on right here. Cranking, and we're running. And let me get I stopped it. Okay. Looks like I got it in one shot. That's not always that easy. And we'll analyze now. Let's start with the first signal. That's our injectors. And I'll kind of isolate the blue guy. I'll bring the red one down, the green one down. And remember, looking at your illustration, that right here is basically a ground. That's the ground voltage being consumed right from the negative side of our injector into the PCM through that driver, that transistor driver, out to the engine block and out to the negative side of the battery. So we want to see we don't want to see any elevation here, any lift on this. That would tell us we have a poor ground. So let's look at the quantity of ground here. Right when I was cranking, and we're going to be about 956 millivolts, which is for cranking is pretty good. So let me go to the next part. This is our crank zone. which we're really stressing the circuit, because of the pull of the starter. So that was our injector cranking. Our ignition coil ground cranking is going to be about, let's see, we'll go right in the middle of the thick part. We're looking at about 511 millivolts, which isn't bad for cranking. Obviously, it's always going to be a little more during cranking. I will check everything in the running state also. And the third one is our map sensor ground. That's a sensor ground. So let's see what that is. That is right in the middle here. We're looking at about 365 millivolts. So that's good for cranking. And the engine block ground, which is, that's where pretty much everybody kind of bifurcates into. It's kind of like a parallel circuit in reverse. When we think of the positive side of a circuit, it starts with one circuit and it parallels off with the ground is kind of the opposite. It always got to get to the negative side of the battery. So, oh boy, okay, I'll deal with that. Oh man, okay. Okay. Let's see. I'll tell you what. All right, we're back in business. Okay, we are. I can't say enough about those Jackeries, that little power port. Just to digress a second, I got that on Amazon. It has so many power ports, USB, great for stuff like this. Anyway, I digress. So where were we? I'm back with the grounds. Let me open this up, and we're looking at green, which is the map sensor ground. We're keying on the cranking zone. Right in the middle, green. We're looking about, what is that? Okay, about 263 millivolts. And I'm sorry, I want to get back to the engine block. We saw that earlier. Just want to look at the channel 4. The gold is the engine block cranking, and that is about 287.5 millivolts. That's the voltage drop cranking, which is good. We're all within spec. So let's kind of look at the running section of the pattern. This is when we're running, and we have less strain. Obviously, we're not cranking. There's going to be less voltage drop. We'll start with the injector right here, and we're looking about what is that? Here to here. That's the delta. That's about 368 millivolts right there. Okay, not too bad, not too elevated. If it were much more than that, you'd know you'd have something that's compromised within the ground loop of that injector into the PCM to the block, and block to the negative side of the battery. So let's go to the next guy, which is red. That's our ignition coil, and we always see this. These are the coil firings which show up in the ground circuit, and I will filter that. Let's filter that, and we'll look at the amount of ground rise. Okay, that's when the circuit is sort of straining when the current is flowing through that coil. That's about 151, and when we're kind of relaxed, I guess there's no current. That technically should be 0 right there, because that's that moment, because this is a sequentially pulsed signal. But nonetheless, right here, where 151 is good for the negative side of the coil, which is hardwired to the engine block for all 4 coils. The third channel, the map sensor ground, which is a sensor ground, which is right here, is about, what do we got here? We're looking about 18 millivolts. That is obviously a sensor doesn't carry the current that a working component like an injector or a coil does, but nonetheless, which explains why our millivolt is low. That's good. That's a healthy ground from the sensor to the PCM, into the PCM, through its logic, out of the PCM, through the logic ground to the block, and then it's got to get to that negative side of the battery terminal which is good. Makes so these four particular tests right here is good if we we have a situation, we're having issue with the scan tool, we're having issues with a rough running, no crank, something. It proves out a lot. The setup is fairly quick because injectors and coils can be obtained fairly easy in an engine compartment. The engine block is nothing. Just clamp a alligator clip to the block, and of course the map sensor usually is pretty accessible. Just look in your service information for the colors of your wires. You have 5 volts, you have a signal, and a ground. And then run it on a fairly slow time base and turn the key on, crank it, and take your ground measurements. You see if you see anything that's elevated. Thanks a lot for watching.